Good morning. In the first of our Friday lectures, I'd like to indicate how to actually write a program to do one of these numerical methods. I think the one I'm going to do will be the method of false position because out of all of the methods that we have, it's the most complicated one so far, and it therefore will let us look at a variety of programming issues. I have the standard tools of the trade, a pen, a calculator, some paper, but most importantly of all, a cup of really strong coffee. I'll be making frequent use of that last one, if not any of the others. Today I'm going to use Silver Frost, so the first thing to do is to get my programming environment going. I will launch Plato, which is the IDE that came with Silver Frost. Up it comes. I'm going to have a project here. So I'm going to go up to File. I'm going to have a new project. We have to give this a name. I'll call it false P, short for false position. And we will say that this is a fortran application that we're going to make. I have my files over here on the side. Source files, for instance. There aren't any yet, so I can't go into that folder. I'm going to add a file to my environment. What kind of file? A free format Fortran file. Something that I always tell people to do, and something that they seldom actually follow up on, is don't type in a whole bunch of code and then expect it to work, because you're almost guaranteed to make syntax errors or errors of some other sort early on. Especially if you're not used to programming, just put a little bit in and then compile it and see if the thing compiles or not. You will save yourself much headaches if you do this. So I'm just going to have something very simple. I'm going to have a program name. I'll call it false position, false P, although it's not actually going to do that yet. I'm going to do the Hello World program. Don't worry, we'll be doing more than that real soon. And then I'll say end program. Every program has to have an end statement. And if I gave the program a name, as in false P, I need to say end program if I want to be careful about it. This file, I have to save it. I need to give it a name. I'm going to call it try1.f90. Then I need to make sure that that's in my project. So I'm going to add an existing file. There's my try1, you see. I'll double click on this. And now this is part of my project over here. As far as the compiling and running of the thing goes, I'll build the thing. It comes down and tells me that everything's fine. It created the executable. It didn't report any errors. And then I go back up here and start the run. The compile does not display this annoying banner. The run does, though, but that's fine. It prints out Hello World to the screen, and it wants me to press return to close the window, which I'll do. So we're going to do something more interesting than printing out Hello World, though. We're going to have some variables. I never have told you guys what implicit none means. Any language that's as old as Fortran does has a long history. Early on in the game, there was only one type of floating point variable. Someone had this idea to make life easier for the programs. The default was if you had a variable whose name started with A through H or O through Z, that variable was automatically assumed to be real, 32-bit real, and the others were assumed automatically to be integer. It was early in the computer game. This probably seemed like a good idea at the time, but it was a terrible idea, mainly because later there was double precision, and then later after that, quad precision, and that default, instead of being helpful, became a pit that you could fall into. The statement implicit none tells the compiler, you remember that old convention about the A through H and O through Z? It's off the table. No default at all, which means, of course, we have to declare all of our variables. Now, when we're doing the method of false position, we're going to need some variables, which we now have to declare. There's going to be a bracket, A to B, so it will certainly need variables A and B. There's also the midpoint, if we were doing bisection, or the place where the secant line cuts across the x-axis if we're doing the method of false position, which we are here. So I need another variable. I'm going to call this other one M. We need to be able to calculate our function values. So I'm going to have something called F, which is also real. Lastly, we're going to go around in a loop. So we need to somehow or the other have a loop counter. So I'll have an integer I. Now I've deliberately misspelled integer so that I can see what happens. So I'm going to go back up to here. I'm going to save all. I'm going to build, and you see it didn't like that at all. On line 4, it tells me there's some sort of error. Statement not recognized, compilation failed. In this particular instance, it's obvious what I have to do. I have to go up here and spell integer correctly. So now we save everything, rebuild, and now there's no error message. So then I can run this. I'm going to have to wait for the banner to go away, but in the meantime, I'll just mention that this program does nothing now. It doesn't even print something out to the screen. So naturally, I get no output, but it did run, and we quickly found that one error. If I had typed in 50 or 60 lines of code and then tried to compile it, that one error would have caused a cascade of other errors. Any other place where you reference variable I, the compiler would complain about it because it doesn't know what I is. If you'll follow this compile every few lines of code, you will catch your own mistakes and not have to worry about this sort of thing. Now, Fortran, like most other languages, has functions built into it. By functions, I mean one of two types. There are intrinsic functions like COS, SIN, EXP, LOG, and so on and so forth. But you can also have user-defined functions, and that's what I want to put in next. This is going to be a separate program unit. It's going to be outside of the main program. There's a whole bunch of different ways that I can do the syntax. I'm just going to do this in as simple a way as possible today. I'm going to have a real valued function, f. And in the simplest way of dealing with functions, I have to have a list of things that I'm going to feed into the function. And again, just like with the program, a function needs to have an end function statement, because later I might have more functions after f, and I need to tell it where f ends at. F, as it stands, doesn't know anything about what x is. So implicit none, which turns off those crazy defaults, though once I do that, I'm feeding x into this function. I have to tell it what kind of thing x is now. X is real. The way I send the value of function f back to the calling program is I say f equals, and then whatever the function is that I'm talking about. In our previous meeting, I kept using f of x equals x squared minus 2 as my example, so we will do that here as well. This is all I need to do, so I end my function. When the main program, or any other program unit for that matter, refers to f open parentheses something close parentheses, what's going to be computed is the square of the something minus 2. And as usual, the 2 I've written as 2.0 out of a sense of paranoia. Before I check and see if this compiles correctly, I want to make a couple of comments. Firstly, if I go up here into the File menu, if I want to save all, it's Control-Shift-S. That's right here. So rather than having to move the mouse around, if I feel like it, which I do, when it comes time to save everything, I'm just going to say Control-Shift-S, and I don't have to do the mouse thing. Also, if I go over here to Build, Compile is Control and F7, and Start Run is Control and F5. So I can take advantage of that as well. So I've put my program in. I'm going to say Control-Shift-S. Then I'm going to say Control, function key number 7. And you see I've got some messages here now. These are not error messages, they're warning messages. M and F and I have been declared, but they haven't been used for anything. If you look at the program, A, B, and M also have not been declared. The error messages for those had scrolled off the bottom of this little window, so I couldn't see them. The computer is warning me that I have declared some variables and then never used them for anything. If this happened in a working program, I would look at that and say, I'm just going to remove all references to this variable. In what I'm doing right now, I'm not going to do that because I'm actually going to use A, M, B, and F later on. Now, like before, every time I put in a little bit of code, I'm going to test it and see if it still compiles or not. So I'm going to test this f function and see if it does what it's supposed to be doing. I'm going to be naive about data types here, though. So I'm going to have a loop. As with the program and the function statements, it doesn't hurt me to go in and put the end do in. That way I won't forget about it. For each I value from 1 to 5, I'd like to print out f of I. Now, those of you who are experienced programmers will notice this is going to probably not go too well because I has been declared to be an integer and excuse me, f expects to receive a real number. I've actually made a mistake here. I've put this loop in before I've done these declarations. This was an actual mistake because I haven't drank enough coffee yet. This can't work, but let's see what happens if you try anyhow. Control Shift S, control function key number 7 to compile, and it doesn't like it a bit. It says there's something funny about the statement ordering. Real cannot appear after executable statements. So see, the compiler caught that mistake for me. I am going to do me some cutting and pasting. Cut. I'll put my cursor here and do left mouse button, paste, and now it's where I wanted it to be. I've got a few extra lines before the declarations. So I'll put my cursor right in front of the R for real and hit the backspace key to delete them. And I'll put an extra line in to make it a little bit more readable. So I'm going to save all, Control Shift S, then I'm going to recompile it again, Control function key 7, and now see there's no error, but there's something else down here. In a call from another procedure, the first type was an integer, kind equals 3, and is now real, kind equal 1. See, it's picking up on the fact that I'm sending f a 32-bit integer, but f expects to receive a 32-bit real. It's warning me, but it isn't an actual error because I, the programmer, might be wanting to do some clever bitwise manipulation, and the compiler is going to let me get away with it. But I'm sending a number 1 through 5 in integer format to a function that expects to receive something that's in 32-bit floating point format. Conceivably, something could go wrong here, even though the compiler is letting me get away with it. Let's run this and see what happens. Control function key 5, and yes, save the configuration and stuff. Runtime error. So that warning that the compiler was giving me is a serious warning. I sure hope this doesn't crash the IDE or anything. So let's go back to here. What is the problem? This I is a 32-bit integer, and F expects to get a 32-bit real format. There is a fortran function that will take an integer value and produce the corresponding floating point value. The name of this function is float. So I'm not going to send f I literally. I'm going to send f the floating point version of I. This whole single precision, double precision, quad precision caused an issue with this. Float on most systems converts to a 32-bit integer, excuse me, a 32-bit floating point number. What if you wanted a 64-bit? Early in the game, they just made up another function called dble to take care of that. Then when quad precision was introduced, everyone looked at each other and said, this is getting silly. We need a unified approach to this, which we will talk about at another time. In the meantime, Control Shift S saves my project. Control function key number 7. It is not complaining about the I versus X thing anymore. So I should be able to run this. Control function key number 5. Yes. It compiled with no trouble. It puts the advertisement up, and shortly we see -1, 2, 7, 14, and 23. I started off life being 1. 1 squared minus 2 is -1, so that first number is correct. The next time around in the loop, I was 2. 2 squared minus 2 is 4 minus 2, which is 2, which is what I'm seeing here. 3 squared is 9. When you subtract 2, you get 7. Function f is doing what I'm wanting it to do. There is no doubt in my mind whatsoever about that. If later my program starts acting weird, I know that it's not function f's fault, so I don't have to look at that. Now, of course, I'm not really interested in just calculating some f values and printing them out, so I'm going to get rid of this. We need a bracket for our function. We need an a and a b value so that the function values at different ends have different signs. So I'm going to look at a equal to 0. I could probably just say a equals 0, and that would be good enough, but it doesn't hurt anything to remind myself of what kind of thing a and b are. B is going to be 5. As a sanity check, print star, comma, character string, f of a, f of b. Now, that's a character string. It's literally going to print f, open parentheses, a, close parentheses, space, f, open parentheses, b, close parentheses, and then a few spaces. It's going to print out that character string. And of course, I actually want to see what f of a and f of b are. These are outside the quote marks, so these are actually going to be numbers that the computer prints out. So Control Shift S, Control function key number 7, Control function key number 5. It compiles with no trouble. I'm waiting for the advertisement to go away, and it prints out -2 and 23. I don't really care what these numbers are. All I care about is they have different signs, which is the case here. Now, we're going to have a loop where we go around and do something several times. Because this is just for illustration purposes, I'm going to go around 5 times. So I'm going to have do I equals 1 to 5. And as I said before, it doesn't hurt anything to put the end to do in immediately after that so that I don't forget about it. Now, I want to do the method of false position. To warm up to that, I could do bisection because that's easier to think about. So I think I'll do bisection first. I'm going to set m equal to a plus b divided by 2. Make a comment. It turns out this is not the best way to write that. We will come back to this at some later date. I've got my midpoint now. What I've got to do is to determine which end f of m has a different sign in function value compared to f of a and f of b, the following is a terrible idea. It's atrociously bad, but the logic is, if I have two real numbers and they have opposite signs, then if I were to multiply them together, I'd get a negative number. So what people who don't know any better often do is to say, okay, look, I'll calculate f of a times f of m, and if that comes up negative, the function has different signs at a and m, so I'll set b equal to m, and if that doesn't happen, I'll set a equal to m. So the way we'll do this in Fortran is if f of a times f of m is less than, again, I could probably get away with just saying 0, close parentheses, then something's going to be done. If this is true, then a and m produce different function values. If I set b equal to m, that's going to give me a smaller interval than I had before, but I'm still going to have a bracket. And let me reiterate, this is a terrible way to make this decision. Else, well, if the first thing didn't happen, and continuing to be naive as I said I was going to, if it's not negative, it must be positive. I'm lying to you, right? It could be 0, but we'll worry about that another day. If the first thing didn't happen, then it's the a that gets changed. Now, looking at this, I don't see much that could have gone wrong with it, but I'm going to compile it anyway to see if I got any error messages. So I'm going to say Control Shift S, Control function key 7. It didn't like something. I made a syntax error someplace. 9, statement not recognized. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. If, open parentheses, well, it looks all right. So what has happened here is I didn't type the equal sign and it caused an error. But because I only put in a few lines of code, there's only a few places where the error can be, and it's not that hard to track down. So I'm going to go in and put the m equals a plus b over 2, which again is a terrible way to calculate that, but at least it's not a syntax error. Control Shift S, Control function key 7, Control function key 5. Yes, save the project. It compiled and didn't give me any trouble. I'm still printing out f of a and f of b at the beginning, but I'm not printing anything else out. So I want to go in and make a little bit more output here. So right before the end of the loop, I want to print some stuff. Print star, comma. I'm going to tell it what I'm printing out. A, comma, midpoint, comma, b, comma, the function value at the current midpoint. And this is a character string. It wouldn't matter if I spelled stuff wrong, but I might as well fix it while I'm here. Beside doing that, I want to print out A and M and B, and I want to print out the current function value. What we want is for f of x to be 0. If our method is working correctly, that last number that I'm printing out should be getting small as we go along. Of course, bisection is slow, so we'll see how this goes. I'm just going to try to run the thing directly. I'm going to do Control Function key 5 and see if I can skip some of this intermediate stuff. It turns out that I can, which is a good thing to know. We have to look at the advertisement, and we get, for our M, 2.5, 1.875, 1.5625, 1.5625 again, and -2 times 10 to the minus 2 power. This needs a little looking at. 1.40625, 1.40625, 1.56. Something funny has happened here. Something interesting has happened. As it turns out, this was due to insufficient coffee consumption. Nothing particularly interesting had happened here. I'm going to change the upper limit of integration, coffee, the upper limit on the loop to 23, and then do Control Function key number 5. Look at the advertisement again. And at the 23rd step, we see that the function value is about 6 times 10 to the negative 7. It might be interesting to see if I can make it much smaller than that. So how about we go around 100 times. Function key, Control Function key number 5. If I use Silverfrost much more, I may actually just buy a license so I don't have to keep looking at this ad. And the answer is no. You continue calculating like this, and the function value is not changing a bit. When we talk about the analysis of these methods, we will figure out why that's so. But for right now, there's an end game to this. Once this gets down to about 10 to the minus 7, it's not going to get any better. Now, in our lecture in class the other day, I mentioned that the method of false position is exactly the same thing as bisection, except you pick the M number differently. So since I have a working bisection code now, all I've got to do is to figure out what the appropriate M is for the method of false position, substitute that in instead of the midpoint formula, and we'll be in business. So in case it wasn't clear, I've got x equal a and x equal b. The function values are the y coordinates of these points. Regardless of what my function looks like, I'm going to figure the line that goes between the two endpoints. One of my endpoints is a comma f of a. The other one is b comma f of b. The slope, I better not use the letter m because I'm using that in my code to represent the x coordinate that I'm going to update with. So I'll just say slope. This is the part you never let anybody see. F of b minus f of a over b minus a. Then I need to know the equation for this line. I know 2 points on it. I know that one, and I know that one. I could use either one of those. It doesn't make any difference. So I'll use the b comma f of b. Y minus the y coordinate of my point is the slope which we have just figured out, times x minus the x coordinate of my known point. And since I'm using the point b comma f of b, that'll just be, well, b, I suppose. What do we want? We want y to be 0. So I want, in this formula, I want the y to be 0. 0 equals negative f of b needs to be the slope times x minus the known x coordinate. This number is going to be the place where the line cuts across the x-axis. This is what I'm going to use as the m in my code. Instead of using the midpoint, I'll use this number. So we have to do a little bit of rearranging. Negative f of b times b minus a over f of b minus f of a would equal this x that I'm looking for minus b. That says if you add b to both sides, the x that I'm looking for is given by this formula. So I'm going to go back to my code and I'm going to take out the midpoint calculation and I'm going to put this in for the m instead. So here we are back in the code. This is the thing I'm going to get rid of. I'm even going to get rid of the comment. M equals, what we had was b minus f of b. I caught my own typo there, so the compiler doesn't have to. Multiplied by the number b minus a, divided by, I have to put this in parentheses or the order of operations is going to get all messed up. F of b minus f of a and assuming that I've caught all of my own typos, this is the place where that secant line is going to cut across the x-axis. That's going to be the m that I use instead of using a plus b over 2, which is the midpoint in exact arithmetic. Let's see if I made any typos and I got my logic straight. Control, function key number 5, compiled with no trouble. And very rapidly, I see that the points I'm looking at are settling down to a number that's about, look at the middle column of A, M, and B, it's settling down to 1.41421, which according to the computer has function value -7 times 10 to the -7 power, which, as we said, in 32 bits, that's about as good as you're going to get. So what have we done? We've learned how to use a function f, for instance. We've learned how to do if, then, else's. We've embedded this in the middle of a loop. We've decided on plus or minus signs in a really bad way, which we'll have to revisit. We've managed to implement both bisection and the method of false position in a very simple way. There's layers and layers of complexity that you could put on this thing. There's all sorts of things you could do, but to get started with, we can now run simple numerical methods to solve f of x equals 0 in a way that is similar to this. So make sure that you can write a program that does this. And if you're feeling ambitious, go ahead and code up Newton's method and the secant method as well. We've basically already taken care of bisection and the method of false position. Later today, I'm hoping to get the first assignment online. If I don't get it done today, it'll definitely be done tomorrow, and you'll have a week to get it done. This should be a no pressure situation, but let me tell you, don't wait till the last minute. It never works out good. You have been warned. I'll talk to you again soon. Coffee. You have